Today we are interviewing the famous Albert Einstein.
Hello, so glad to see you here. By the way, sometimes I like to not talk with my mustache on.
So Albert, tell me when you were born.
I was born in 1879, the same year Thomas Edison made the first light bulb. It wasn't necessarily the first light bulb, but it was the first cheap one. And this caused my father to get into the electrical business. And that's how I got into science.
Wow. Well, we can't get into all the details of your life, but I would like to know, what was the most significant year?
1905.
Wow.
That year was my miracle year.
Oh my. What happened?
I published this one, this one, and another one that we do not show here. So, we're going to start with the one I learned my proud Nobel Prize of Physics. Not Nobel Peace Prize, mind you. It's about the photoelectric effect. Essentially, it's you send a photon. If you send a photon at a piece of metal, the other side of specific metals, the photon will go through the metal and be turned into an electron. But if an electron tries to go through it, it will bounce off. This is required in almost all electronic circuits, making it very important. Also, later on, we figured out that this means that waves and particles are related. But less like the special relativity and equivalence of mass and energy related, but more like they can be in both, but they're both at the same time. Something can be a particle and a wave. And this led to quantum theory being formalized.
And can you give me an example of how the photoelectric effect might affect us today?
Photoelectric effect? Well, we're taking this video with a phone, and that phone requires the photoelectric effect to be made.
And what do you think the future is of quantum?
So quantum is being used to make big computers. The way normal computers are is that there's a bit. It can either, with that radiation stuff I'm talking about, it can either, if there's an electron, it can either be coming through or not coming through. If it's coming through, it's a 1. If it's not coming through, it's a 0. Quantum computers can be a 1 and a 0 at the same time. So for example, and so the exact way binary works is, let's say I have 4 numbers. I have 4 digits. And I want to make, let's say, 10. I want to say, the first, if I put 0 here, then if 0 will always equal 0. It will add no numbers. The first one gives off 1. The second digit gives off 2. The third digit gives off 4. And the final digit, and the fourth digit, gives off 8. So, 0, 1, 0, 1 is 10. And once you can use numbers, you can have numbers mean things. So let's say 10 means pressing the print F, a letter on the keyboard in the application Word. With a quantum computer, you can be at both states at once. And this greatly increases the power of the computer.
So that is the effect of Albert today.
Yeah.
Signing off of Photoelectric Effect. Be back with another theory.